Hello, welcome to my YouTube channel once again. In this video, we are going to discuss about perfect numbers. So, what are the perfect numbers? Is the definition is that if sum of the factors, if sum of the factors of any number, if that is equal to the number, then that's a perfect number. For example, you have for 6, the factors are 1, 2 and 3. And then 1 plus 2 plus 3 is equal to 6. And then for 28, we have, these are the factors of 28. And then sum of, if you actually do the sum, 1 plus 2, 3, 4, 7, 14, it will be like 28. So how can I, okay, if that is the definition, then what could be the next perfect number? Because these two are relatively easy to find out the perfect numbers if it is, because they are smaller numbers. So the formula is that somebody found out, some genius found out that, okay, if 2 power p minus 1 is a prime, okay, then 2 power p into 2 power p minus 1 is a perfect number. For example, you have, 2 power p minus 1 is a prime, right? So for example, you have 2 square minus 1, that is 3. That's a prime. Okay, so 2 square into 2 square into 2 square minus 1. Then actually that's a 6. That's a perfect number. Okay, so what is the next 2 power p minus 1 is a prime. So the next prime for 2 power p is, let us take 2 cube minus 1, that is 7. 7 is a prime. Okay, and so oh sorry, this should be like 2 power p minus 1. Yeah, sorry to say that. Yeah, so this is 2 power p minus 1. So that means that actually it is like 2 power 1. Yeah. So yeah, so if 2 cube minus 1 is a prime, that's a 7, that's a prime, then 2 power p minus 1, that is 2 square into 7, that is 4 into 7, 28 is a prime, is a perfect number. Alright, so next we need to hit upon, because if you want to find out next perfect number, then we need to apply this formula. Okay, so what is the next perfect number could be is that 2 power, next you need to hunt for 2 power p minus 1 is a prime. So 2 cube minus 1 is a prime, so that works, but 2 power 4 minus 1 is 15, that's not a prime. Okay, so next one is 2 power 5 minus 1, that is 31, this is a prime. Alright, so then the formula is like 2 power 4, because it's a 5, right, into 31, that is 16 into 31, that is 496. So 496 is actually next perfect number. Okay, so there is, we can verify this factors of 496 and then see whether the sum of its factors is 496 or not. You will find exactly that, it's true. So this formula is actually is true. Okay, so since the perfect number is actually it's a 2 multiple, right? So we have only even numbers as perfect numbers so far. Somebody tried to prove that if there is any odd perfect number, that means that odd number in this right hand side is some of its factors. Okay. So far, nobody could find any odd perfect number. So far, every perfect number we find that is even. Why? Because this is the formula. So either we have to say that okay, if the sum of the factors is the number, then this should be the formula. Either we have to prove that way, or we have to prove that okay, if the right hand side is right, for example odd number, then it results in some contradiction. So what we are going to do is that, I mean, how can we prove that sum of the factors is equal to number? Then that should be in this format, in this form. So we try to see whether we can prove this, we can derive this from the, from the rules, from the mathematics, from the fundamentals of mathematics. Okay. All right. Okay, so okay. So generally what happens is that since the factors, like for example you have, definitely every number is kind of a multiple of primes. Okay, and it is like that. Yeah, it is like that. Every number is kind of a multiple of either it's a prime or multiple of primes. Okay, take any number. Take 14, for example. Just now it is like 7 into 2. Okay, so I mean you can write it as 7 plus 7. So if you take its factors, right? Its factors. 1 plus 2 plus 7. I mean 7 is a duplicate. So 1 plus 2 plus 7, that will be like 10. So if the number is kind of a 2x, I mean it's even. Let us assume that the number is even or number is odd. Okay, we will try to see that whether if I have number is odd, right? 2x plus 1. So what could be the factors of 2x plus 1? Definitely 2 is not a factor. Okay, for every number 1 is a factor. Okay, so 1. And then 2 is not a factor for any odd number. So any of the multiples of 2 cannot be a factor for odd number. So there is a chance that only the odd numbers are the factors of odd number. So the next possible factor for 2x plus 1 is actually 3. Okay, and then if I talk about next odd number, okay, the 5. Okay, then next odd number, like for example, you have 7. Okay, so let us assume that okay, we have a number where only it has got odd numbers. Okay, if you sum of the first odd numbers, actually it is like square of number. For example, you have 4 first odd numbers, right? 1, 3, 4, 9, 16. That is 4 square. So that means that is a kind of even number. So if you take about, okay, if I take about first 1 plus 3 plus 7 plus 9, that will be 25. That is 5 square. Alright, so but 25, I mean these are not factors of 25 by the way. So that's where the proof becomes a little bit complicated, in the sense that if you have an odd number in the right hand side, right, then 2 cannot be factor, and then only odd numbers are the factors. If I have all the odd numbers, then we result in something else. It results in some squares or cubes or something like that. Okay, so alright, so let us assume that we have a factor, like for example we have, okay, so you have a first odd number like 2y plus 1, okay, and then it will be like this, it will be like 2x plus 1 by 2y plus 1. equal to 2x plus 1. Generally what happens is that let us assume that you have just two factors. Okay? Odd number and then let us assume that the odd perfect number is 2x plus 1. Then the next factor will be 2x plus 1 by 2y plus 1. Okay, this is 2x plus 1. Okay, let us assume that only 2x plus 1 has got two factors. One is this and the other one is divided by that. Okay. Now you try to see whether we can come up with the equation. Alright, so it will be like what? 2y plus 1. Alright, so I can cancel out one here, one there. Okay, so you have what? You have 2y plus 1 whole square plus 2x plus 1 equal to 2x into 2y plus 1. What this means is that this is 4y square plus 4y plus 1 plus 2x plus 1 equal to 2x into 2y plus 1. Now I will take this here. So 4y square plus 4y plus 2x plus 2. Okay, equal to 2x into 2y, 4xy plus 2x. Okay, so 2x gets cancelled. Okay, all the 2's can be cancelled. So 2y square plus 2y plus 1 equal to 2 into xy. Okay, so this is what? This is 2y into y plus 1 plus 1 equal to 2xy. Now you see that this guy is even. Even plus 1 is odd number, whereas this guy is actually even. So we cannot have any number with just two factors, two odd factors into it, and then it results in a contradiction. So what we need to prove is that generally if the odd number is there in the right hand side, then if it has having two factors, if it is having at least one factor, right? And then because those two cannot be equal. If they are equal, then that is odd, that is not a odd number, that's even number. That will be 2 into something. Okay. So then let us assume that okay, if it has to have the factors, it should have at least, let us say 2y plus 1, 2x plus 1 by 2y plus 1. If it is having another factor, then it should have, some other number. So that means that, so let us suppose that you have 2y plus 1 or 2z plus 1 are factors. Are factors of 2x plus 1. Because odd number can have only odd number factors. So these two are factors. Alright, then let us see whether we can derive, we can derive perfect number formula from this. Okay, so now 1 plus, alright, 2y plus 1 is the factor. Okay, and then 2z plus 1 is another factor. Okay, and we have number is like 2x plus 1 by 2y plus 1 plus 2x plus 1 by 2z plus 1. If this is the factor, this also should be factor. Okay, that is 2x plus 1. Okay. Similar to what we have proven for two factors, it is like 4, there are total 5 numbers there. So we can actually prove that this results in odd number that results in even number. Yeah? Okay, so 2y plus 2z. Here 2y plus 2z plus 2. Alright, so 2x plus 1 by 2y plus 1 plus 2x plus 1 by 2z plus 1 equal to 2x. Okay, so imagine this, since the odd number cannot have even factors, even this is odd number, This is odd number. So odd, odd. Okay. Okay. If you take 2 into y plus z plus 1 plus 2 into y plus z plus 1 plus odd, this is even, this will be like 2x. Okay, so we need to go a little deeper in the sense that we need to, quarterly factorize this. Okay, so 2 into y plus z plus 1, 2y plus 1, 2z plus 1. Okay, plus 2x plus 1 into 2z plus 1. Right, then plus 2x plus 1 into 2y plus 1 equal to 2x into 2y plus 1 to 2z plus 1. Okay, so yeah, we can cut it down and then we can see whether we can simplify this. Okay, so we will try to simplify this, then it may take some time, but yeah. Alright, so this is actually the even number, right? So, okay, 2x plus 1 into 2z plus 1, it will be like what? So, alright, so we have. Alright, so we will actually, I'll try to prove this in the next video because it's a lengthy formula. So, till then, have a great time. Thank you very much.